In this video, we're going to look at the following sequence of numbers 1 over 1, 1 over 2, 1 over 4, 1 over 8, 1 over 16. And we want to find out what happens if we add up a whole bunch of these numbers. In mathematics, we would actually like to know what happens if you add up an infinite number of numbers. In the computer, we can't really add up an infinite number of numbers, but we can add up a whole bunch of them and kind of get an idea of what the infinite sum would look like. So to model this, I think we need a sum variable. You'll notice I made it a decimal variable because I'm adding up fractions, so there'll be a decimal part to this number. And what I'm seeing is that the numerators are always 1 and the denominators are always, well, it starts at 1 and then that number gets doubled and then that number gets doubled again. So I'm going to have an in variable that's 1. And that number will change while my loop runs. So I have to pick how long my loop will run. I'll start it at 1 and have it run, I don't know, 1,000 times. I'll probably change that in a minute. And then the strategy is I'm adding to the sum 1 divided by n, and then I need the denominator to double for the next number. So when n is 1, I'm adding to the sum 1 over 1. Then n doubles to 2, so next I'll add in 1 over 2. Then n will become 4, so I add in 1 over 4, etc., etc. So by the time this method is done, the variable sum should have the sum of the first 1,000 fractions in that sequence. So let's see what that looks like. Oh my god, it's 2. Who would have guessed? To show you a little bit more what's going on here, if I started at like this loop running only twice, you get 1.5. I make it run 3 times, it's at 1.75. I make it run 5 times, 1.9375, 10 times, 1.998. If I run it 20 times, it's now at 1.999998. And so as I'm adding more and more terms into the sequence, it's getting closer and closer to 2. What ends up happening when the number get closer, sorry, let me say this again. When n keeps getting bigger and bigger, this fraction keeps getting smaller and smaller to the point where the computer doesn't even keep track of the decimal place anymore. So when I was getting out to the 1,000th fraction, nothing was really being added anymore. And the computer here is rounding the number to 2. But it is actually a true fact, if you added up this infinite sum mathematically, it would be defined to have the value of 2. And our computer is showing this with a simulation that as we keep adding in more of these fractions, it keeps getting closer to 2. So hopefully that demonstration made a lot of sense.